Hello, back for another project from 21 and 21, the second project in the FinOps series. This time we're going to be looking into Stripe. This project builds pretty much directly on from the previous one, setting up everything in Vercel. We created an e-commerce app last time with a sort of placeholder for Stripe, and then used Cursor's Cursor 2.0's new features with the element editor and the in IDE browser to go and make some changes we wanted, tidy some stuff up, and then yeah, now we're here, and we hosted that, and now we're here. So yeah, this one is on Stripe, setting up Stripe into that checkout page. Cool. Okay, so we're going to build a secure checkout flow that prevents price manipulation and verifies payments the same way Shopify and OpenAI do. Yeah, it's really, it can't be understated how big Stripe is. They are the online payment provider, and understanding how they work and then how to add security around what they do. It's a really good thing to understand and know. And this workflow is super useful as well. Setting up Stripe is a really good skill to be able to bring to the table for designing applications where payment is required, which is a lot of them. Yeah, so this is a pretty easy project, a little bit longer than the last one. Last one was about 45 minutes. This one's about 60 minutes. It should be free. There's no cost involved here. Cursor can cost money, but you don't have to have a paid account to use it. So that's good. And then so we've got part one, previous one I just talked about, which is definitely recommended. We catch you up in this project if you are, if you haven't done it yet. But definitely recommend doing that in its entirety. And then, next one is the post-hoc analytics, which is, post-hoc is a platform which a lot of people use, a lot of companies use to understand metrics and see patterns and trends on apps. It's a little bit like Grafana, but really specific to this sort of thing. So looking at hosted applications opposed to, polling and data from different data sources and stuff. And so the key concepts we're going to be going over using here is AI, Stripe, Vercel, and Next.js. Cool. So here's a 30-second summary. Companies like Shopify, OpenAI, and Etsy process billions of dollars through Stripe, the payment infrastructure that handles PCI compliance with 300 plus security requirements. You don't have to. Your job is never to break that boundary by mishandling keys, skipping Webhook verifications, or trusting front-end prices. Most developers make the same mistakes, hard-coding secret keys in front-end code, accepting prices from JS, or assuming successful redirects means payment complete. One compromised key or skipped verification and you're liable for fraud. Professional teams use battle-tested patterns, secret keys and environment variables, server-side price lookups, and cryptographic webhook verification. These aren't optional security theater, they are minimum for handling money. Stripe processed over $1.4 trillion annually because developers trust these patterns. Very good. Cool. So what you'll build in this project, you'll integrate Stripe checkout into a Next.js application, one we just built in the previous project. With proper security practices, you'll use Cursor 2.0 to build server-side checkout sessions, configure Vercel environment variables for key management, and implement Webhook signature verification. This is sort of the system we're going through here. You've got a user accessing an app here with server-side pricing. We'll touch on what that means in a minute, but it's effectively something that can't be manipulated by someone that's trying to manipulate it. Maybe someone that's trying to decrease the cost of an item on a site. So
Then you've got a hosted checkout, which is PCI compliant. That's Stripe. That's the main focus of this. And then we've got our webhook endpoint. Yeah, which we'll explain when we get there, but it's another level of security to make sure, and we'll go through showing the before and the after of before we'd set up something and after we'd set up something, highlighting that you can, or there is security benefits of setting up webhook signature verification. Cool. So is Stripe free to use? Yes, for development. Stripe's got a really good test mode that helps you build and test payment flows without processing any real money. You'll just need API keys, and they give you test card numbers, so you don't have to spend any money to test anything. Yeah, it's certainly a really good thing that they've provided the test mode. It's great to go and just do development things like this, and you can use it for much more as well. This is a pretty basic use, but yeah, it's really good. It just lets you go through the pipeline, make sure everything works the way you want it to before you even set up like a proper Stripe account with a bank account or anything. You just Stripe. Stripe powers payments for over 1 million merchants worldwide, from startups to Fortune 500 companies. Instead of building your own payment form and taking on massive liability, you direct users to Stripe's hosted checkout page. Card details never touch your servers. Stripe handles card validation, fraud detection, and PCI compliance. In this project, you'll create checkout sessions, server-side, and verified payment confirmations through webhooks, the same patterns used by professional e-commerce platforms. So there is kind of a prerequisite for this. I say kind of because we do walk you through it if you haven't done it, but so it's still kind of as a prerequisite in that sense. This project builds on shipping a landing page with V0 and Vercel. You'll reuse your deployed Next.js application and Vercel project from part 1. If you're not sure if this project is right for you, you can use the Ask feature here to send a chat message to the AI here, and it will give you, it'll tell you if it thinks it's the right option for you based on a bunch of stuff, what projects you've done well in, or just done, sorry. Definitely recommend it. So how we're going to build this. First, you'll set up Stripe with proper key management, learning why publishable and secret keys exist and where they each belong. Then you'll create server-side checkout, a server-side checkout flow that ignores front-end submitted prices. Finally, you'll implement webhook verification, so you only fulfill orders that Stripe confirms, cryptographically confirms. By the end of this project, you'll have a secure checkout flow that redirects to Stripe's hosted payment page, a server-side price calculation that's immune to front-end manipulation, webhook signature verification that prevents fake payment confirmations, and then if we do the secret mission, or if you do the secret mission, we will in this video, you'll have a discount code system validated entirely server-side. So that's like you can put in welcome 20 and it will give you 20% off. So setting that up with Stripe is what we're going to do in the last part, secret mission. Cool, we'll come back to the quiz at the end. Cool, so choose your mode. We're going to go with high touch, but there is totally, if you want to go down the path of low or no touch, you can totally do that. And if you're ever stuck, you can go to the Next Work community for help. Cool, so we're going to connect our app with Stripe. Time to connect your app with Stripe. We'll set up a Stripe account, get your API keys, and configure them so your app can accept payments securely. In this step, get ready to create a Stripe account and get your API keys. Configure keys in Vercel and locally. Cool, so in this step, I'm going to create a Stripe account and get my API keys by viewing them from the Stripe dashboard. This is important because for my web app to
communicate with Stripe, it needs access to my API keys. Cool. So what are we doing in this step? In this step, I'm going to create Stripe accounts and get my API keys by viewing them from the Stripe dashboard. This is important because for my web app to communicate with Stripe, it needs access to my API keys. Awesome. Okay, so we have here, have you deployed the Vercel project from part 1? If you have, that's great. We'll move on and we can check if you've created a Stripe account. We'll go forward depending and act dependingly on whether you've created a Stripe account or not. But yeah, if you haven't done this project, you can walk through here and go and set up what you need to go and get to the same point as we were at previous. But totally fine if you haven't done that. You can go down here, and if you have, we'll go and continue to set up the rest of the project with Stripe payments. Cool. So yeah, depending if we already have a Stripe account or not, we can go down these two tabs. I actually do have a Stripe account, but I think it's worth going through and setting up this again, so I will. It's not a very long process, but it's definitely worth, definitely could be worth for some people stepping through this. So I'll do this. What I will do though is, because like I said, I do have a Stripe account. So I'll just open up another Google Chrome profile, and I will create a Stripe account over there. So we'll move to this profile. Go start now, and I'll just do a split screen thing here. Cool. So we will just put in this email account, this Google accounts information. Cool. I will delete this account before this is published. Shouldn't take too long to load. Just a few seconds. Cool. Okay. So we can skip these screens here. We can click skip for now. A few times. We can click go to sandbox. Cool. So 1 second. We should just be able to refresh this. Oops. And then we should just send. I'll just open this inbox up, and then we can verify the email. Cool. Okay. So to refresh the page, if you click on verify email, it will let you just skip this, and you can refresh, and then you can just close that. Because we're just using basic functionality with the API keys, and we're just on a free account, this is totally fine. We don't need to actually entirely set up Stripe. Feel free to. It's not going to damage anything. It'll make our project any harder. It'll just take a bit longer to do that. So yeah, we'll just skip that for now. Cool. So we can see our API keys here, or at least part of them. So yeah, that's good. You can copy them as well. What are these? There's two different types of keys. There's a publishable key and a secret key. Publishable key is safe for front-end code, so we're going to be using that. So it can only create payment tokens, and a secret key can change, so it can charge a card and do sort of all of like the important stuff you wouldn't want someone else to be able to do on your behalf effectively. So that's not a good idea to put in front-end code. And that, I mean that literally. It's not like, just because it is on, you're not, printing the word, it doesn't mean it's not accessible with, simply just inspecting the page and going and finding it. So yeah, it is crucial. It's not so much the publishable key, but the secret key is never used. Is never used to in the front end, so someone can access it or has the chance of accessing it if you did the wrong thing with it in the front end. Cool. All right, let's upload a screenshot of these keys. Obviously, it's not a big deal to do this much of an API key. We wouldn't ask for you to take a screenshot of a published API key that you can see the whole thing of, but or all of, but we can only see a little bit of it, so it's fine. What's the difference between a publishable and a secret key? Publishable key is used for front-end code where can only create payment tokens. I think that's what it said. Yep. The secret key is used for doing more. Let's see, for the backend, doing more heavy lifting, e.g. Charging cards, issuing refunds, etc. It's not really true. You not necessarily for the backend. It's for doing more heavy lifting, e.g. charging cards, issuing refunds, etc. Cool. So what's the difference between a publishable key and a secret key? The publishable key is used for front-end code where it can only create payment tokens. The secret key is used for doing more heavy lifting, e.g. Charging cards, so getting people to pay, and issuing refunds, and other stuff too. Cool. So let's add our secret key to Vercel. This is important because with our published site, which is what we did in the previous project, we published it on, or hosted it on Vercel, and we can set something up locally, and that's great. But we don't really want to be pushing our .in file, environment variable file, to Git, which is the only way that Vercel could theoretically get access to it. That's a really bad idea. Don't do that. So we're not going to do that. We'll just directly go into Vercel and give it something, so it knows when it runs the code remotely what these variables are, like the Stripe secret key. Cool. So we'll go here, and so we can go to. Might just minimize this for now, and then here. So we can select our app. Oops. The app. So we'll navigate to. I'll just zoom out a little bit so you can see. Zoom out a little bit. There you go. settings, environment variables. Cool, and then we can go and add our Stripe key. So if we, or secret key, sorry, Stripe secret key. If we go back to the dashboard we had here, and I copy that secret key, and I paste it in there, and I save that. That's saved, so that's now linked to, well, as you can see in the bottom right, I'll explain not the current deployment because it needs to be redeployed, but the next deployment will have that information, which is fine because we haven't actually done anything yet, and that's what this sort of points out. We don't actually need to redeploy right now because there's no more information, well, there's no code using this secret key. So that's all good. We'll deploy by pushing it to Git shortly. So no need to do that. You can do it if you want to. It's not going to break anything, but it's not required. Now we're going to do sort of the opposite of that, or the opposite, like the local side, I guess, if that was the remote side. We're going to do that. So I'll open up Cursor. Yeah, so it's kind of, they're both local relative to where it's being hosted, but this one's on our machine, the one we're setting up now. Cool, Cursor just opened over here. Just zoom in a little bit. I'll put this. So we're going to right click here, we'll click new file. We're going to call it .env.local. You can also call it .env. Just have to be aware of the rest of the code when you're doing that. Cool, and yeah, we'll go back to our Stripe dashboard. Probably need to something up. Copy the secret key again. We can put it into here, and copy this and paste it in there. Awesome. So we will take a screenshot of this. Awesome. Why do we store the secret key in environment variables instead of code? I store the secret key in you can see this sort of circle with a cross through it on the side of this file here. It highlights that it's in a global ignore, so it doesn't get pushed to GitHub or anything you wanted to, anywhere you're trying to move this file to with Git. Okay, cool. So I stored the secret key in a .env file because I wanted to be sure that no one gained access to my secret key, my Stripe secret key, because, or as this could result in extra charges for my also payments for my clients. Cool. We could say a .env file does not get committed to Git, keeping this sensitive information safe. Cool, so why do we store the secret key in environment variables instead of code? I stored the secret key in a .env file because I wanted to be sure that no one gained access to my Stripe secret key, as this could result in extra payments for my clients. A .env file does not get committed to Git, keeping the sensitive information safe. Cool. So this is a little bit on what if your secret key did get exposed. So rotate it immediately. I'll definitely do this after the video. I'm going to delete the account, but still, really good practice. Good example, if you did something like this and you didn't rotate it and it was a paid non-test account, it could go pretty wrong. But you can head to the Stripe dashboard, and this little developers thing in the bottom left. You can click on that and then go to API keys, and then you can go over to hover over the ellipses and then select rotate key, and that'll just refresh it effectively and give you a new one. Obviously that means the old ones won't work, so you have to update them, but that's a lot better than having someone else have access to them. So yeah, just be careful of that. And if you need any debugging hints, you can definitely go to the Ask feature over here, or go to the Network community. There's a great community over in Discord. Definitely highly recommend. Cool. So now we're going to build the checkout flow. So great work setting up the Stripe keys. It's time to build the actual payment flow. So you'll integrate Stripe checkout, the same hosted payment page used by Shopify and thousands of other e-commerce platforms. By redirecting to Stripe's page, card details never touch your servers. This drops your PCI compliance scope from the 300 plus requirements to around 20. So in this step, get ready to create an API route for any checkout sessions, connect your checkout button, and test payment flow. In this step, I'm going to add Stripe to my checkout / payment flow. I'll go by adding the by creating an API route for checkout sessions. Cool. This is important because it allows to focus on only 20 requirements opposed to 300 plus to become PCI compliant. And we can actually ask the ask feature here what what that means. We'll give it some time. Come back to that. So what are we doing in this step? In this step, I'm going to add Stripe to my checkout payment flow by creating an API route for checkout sessions. This is important because it allows us to focus on only 20 requirements opposed to the 300 plus that would be required to become PCI compliant if you were doing this by hand or setting up a payment form by hand. So here's an example of using the ask feature here. So PCI compliance refers to payment card industry compliance. So yeah, it's data protection, penalties, and building trust. It brings up, which is all really good. So yeah, definitely use the ask feature whenever you get the chance, or if you see fit, I should say. Cool. So we've opened up this, and now we're going to go into the chat. So we can press Control L to open that up. Zoom out a little bit, it's a bit bigger. And we can send off this first prompt. I will note it says installing their packages. They're already installed for me because I've already done this project, the previous project, sorry, which is effectively what we're looking at now. So just installing that. But it's in the prompt we give, because if you haven't done that project, then that'll be required. But it doesn't have any negative effect. Cool. It seems Curse has decided to sort of do the next step for us. I'll walk through how to do it anyway. It's that is neat though that it did it. But you can open the Curse's browser, so I'll close this. But we're going to get back to there. We'll Control Shift B to open the browser, and this is running on localhost, as you can see there, localhost 3000. So that's what Cursor opened up. But yeah, cool. So we're on this page. And if you're unfamiliar with what you're looking at, this is the website that V0 generated for me when we were going through and doing this in the previous project. It will very likely look quite different, but that's just what this one looks like. So yeah, cool, woohoo, look at that, your web app is running inside of Cursor 2.0. How good. What is Cursor's built-in browser? It's a browser inside your IDE. You can view your app and select UI elements and send them directly to Cursor's AI chat. No more copy and pasting file paths. I think this is, like we touched on this in the previous project and we're using in this one, this component selector here. So you go and click what you want and you can pass that component and resize it and whatever and add blur and all these sorts of things to the chat. So that's really cool. We won't dive too deep into that. It was a bit of a previous project. We'll be doing it a bit later on too. Yeah, so we'll just take a screenshot of this running in the browser, or inside of the IDE really, which has a browser. Cool. So what can you do with Cursor's built-in browser? Cursor's built-in browser lets me select UI components and view the CSS. Use the AI chat. This is useful because it allows us to feed in, to directly feed in components to the to Cursor's AI chat, say opposed to describing them. Cool. So what can you do with Cursor's built-in browser? Cursor's built-in browser lets me select UI components, use the AI chat, and view the CSS. The CSS is this thing here. Well, I should say this is the CSS, to be clear. So this is useful because it allows us to directly, allows me to directly feed in components to Cursor's AI chat, opposed to just describing them. So rather than saying make the text the complete platform to build your workflow bigger, you can click on it and then go into here and then make the text larger, make the font larger, or expand it, or do a bunch of different things. So yeah, it's really and you feed that into Cursor's chat and it goes and acts on it. Cool. So create the checkout API route. Now we need a server-side API route that should say route that creates Stripe checkout sessions. This is where we set the actual price. Never trust the prices from the front end. In Cursor's chat, send this prompt. I'll explain what this prompt is in a second. So we're saying install the Stripe npm package and create a checkout API route that uses Stripe to create checkout sessions, defines the product price server side, never accept prices from like the front end, so what other people have access to, accepts product info from the request body, but looks up real prices server side, creates a Stripe checkout session with server side price, returns the checkout URL, uses Stripe key from environment variables, and redirects to /success on completion and /checkout on cancel. That's just the prompt and put it there. So why define prices server side? A malicious user could modify front-end JavaScript to send price 1 for an expensive item. Your backend accepts the front-end price. They pay a cent instead of $5.99. By defining the price on the server, we ignore any price on the front end might send. So if you want to learn more about price manipulation attacks, you can totally send something off there to the ask feature. But we'll be going ahead from here. So upload a screenshot of your checkout API route. I think it's finished, so we'll just go into the file. Zoom out a little bit. I'll keep that open. Cool. Why must prices be defined server side, not in the front end? The price is defined on the server side because if the front end controlled it, a user that malicious user could update this using what do we say? Well, that using a browser console is one way of doing it, I suppose. Using any sort of like curl or anything could do that, sending a request with header information or updating it. Using a curl / other request method. Front end controlled. Because the front end was controlled. The price is defined on the server side because if the front end controlled it, a malicious user could update this using a curl / other request method to a lower price, resulting in a lower cost for the user. Cool. So why must prices be defined server side, not on the front end? The price is defined on the server side because if the front end controlled it, a malicious user could update this or the pricing using a curl / other request method to a lower price, resulting in a lower cost for the user. Cool. Sweet. So now let's go and close this for now, and let's go and link up that wire up that checkout button to call the API. So in the Cursor browser, enable element select mode, so that's this button up here. We'll go to the page we want to wire it up to. So we can go here, oops, we can go here and just make this full screen again. And we can select the component here that we're interested in implementing Stripe in. So the selected opponent gets attached to your chat. Ask Cursor to implement the Stripe payment API here. So we haven't provided a prompt. You can sort of just freestyle something here. Add the Stripe payment API route to this button. Cool. So it'll go off and do that. Shouldn't take too long. But yeah, it's just using the API route we just created to go and turn that to a functional button, which looks like it has. We'll see. I think we have. I'll just turn that off now. I think we have something that's common here is if you haven't set up in .env local and this wasn't configured, then it could cause an issue. So we'll see if this works. Cool. Okay, that looks like it went through. I'll just click back so we can follow along. So click the checkout button at the start of the payment flow. Cool, we're on a Stripe page, so I'll just put in some details here. And yeah, you can test with this pass there, and then any information here, it will work fine. Cool. See if that goes through. And that's actually expected because it hasn't created a success page, so that's fine. I wouldn't worry too much about that. We've gone to /success, so that's all good. It just didn't create it. Vercel didn't create it. Well, V0 didn't create a success page, which is fair enough. Cool. Cool, so payment was successful. We saw the /success page, which is really cool. And we can actually go and look at, if we go to this, full screen it, I think if we refresh we should see, a payment come through. Cool, there you go. So payment came through. Very good. Alright, so it worked for us. Payment successful. Excellent, you've just processed your first Stripe payment. The redirect to Stripe's domain is crucial. It means you're using Stripe checkout hosted, which handles all the card security for you. If something went wrong, that's completely fine. As I pointed out, environment variables are the most common thing probably, but you're welcome to reach out to the network community or use the ask feature here if you need any help. Cool, so let's verify payments with Webhooks now. This is step 3. This one's all about security. I suppose the previous ones were too, but this is really a focus on that. So yeah, verify payments with Webhooks. Excellent work. Your checkout flow is live, but here's the thing. The success page isn't a proof of payment. Anyone can directly go to /success without paying. The checkout redirect tells the user the payment succeeded, but you need cryptographic proof. That's where webhooks come in. They're how Stripe officially confirms payment completion. Let's first see why this is dangerous and fix it with a signature verification. So in this step, get ready to create a webhook and expose its vulnerability, and then add signature verification to block fake webhooks. So I'll just be clear, this is not like some sort of big flaw in Stripe's payment mechanism. It's very secure, but you can, if you're going to open a webhook, you can make it vulnerable, and that's sort of what we're trying to highlight with this. So yeah, that's just to be clear there. In this step, I'm going to create a webhook and expose its vulnerability. Oops, vulnerability, and then fix it with a or fix it by adding. Oh, bias the next by implementing a signature. Okay, signature verification. This is important because we need to be able to understand that. What do we say up here? That a payment has been completed. Cool, so what are we doing in this step? In this step, I'm going to create a webhook and expose its vulnerability and then fix it by implementing a signature verification. This is important because we need to be able to understand that a payment has been completed. Cool. So we're going to create a basic webhook endpoint now with a flaw. And we're going to see that flaw in action, being able to post something to it, and then we're going to go and fix that. So create a basic webhook endpoint. First, let's create the webhook endpoint without any security to see why that's dangerous. We're going to open up Cursor's chat again, and then we're going to send off a prompt. Cool, so we'll just send this this prompt off to create a basic webhook to Cursor. This, like I said, is without security, so we're going to be able to see some faults when we run a vulnerability test with this command shortly. It shouldn't take too long to go and implement this, probably another 30 seconds or so. And then we can run this command, and hopefully we can see that it returns without any fault. Give it a second, it's almost done. It looks like. So we'll just go open a new terminal here. Cool, so it's just hopefully created a route. Okay, it is empty. I'll just get it to recreate it. I've had this problem before with Cursor not wanting to create. Probably could copy this code and okay, cool. Alright, let's see if this works. Might need to prompt Cursor to fix something. I don't know if it seemed to have a little bit of trouble filling out this route file that we've asked for the webhook, but we can try anyway. So I'll just send this command off and see if it's okay. Cool. Looks like it hasn't worked. A bit of debugging then. The route you created appeared to be empty. Can you double check what's going on? I'll send the PowerShell command. So there's a little bit of live troubleshooting here. I think Cursor had a little bit of trouble creating this route thing, and I might not have copied the right thing in here. Okay, it looks like Cursor has created the route file, so we'll try run this again. Cool, that looks great. So this is a confirmation saying security warning because we're executing something here. Pass the content of the web page, script code, and the web page may be ran when the page is passed. So yeah, just giving us a little warning there. We'll just go ahead with this anyway. That's fine. Cool, so we can see that it has in fact succeeded at passing information. We can have a look at this over here, I guess. Obviously a fake signature, not something where like fake signature 123 is not something we want to be accepting. But because we have no signature authentication set up with a webhook, this passes. So and in here we've got kind of pretty random stuff that's not super relevant. You wouldn't want someone to be able to inject this into your web app with a webhook. So yeah, what we're going to do is now go and fix this so it doesn't happen. Cool. So if it did fail, like I just got, clearly could be an issue with Cursor's response. I'm not sure if this was something something that this happens a lot, but it was having an issue where it couldn't write to this file for some reason, but that's okay. Yeah, so yikes, your server accepted a completely fake webhook. In your app fulfilled orders based on this, and attacker just got free products. Oh no, this is why we need signature verification. Alright, let's add signature verification. So what we'll do is we'll send this prompt off, and then I'll explain what it's doing. So, read it from here. Update the webhook endpoint to verify Stripe signatures. So the webhook endpoint is what we just designed up here. We just did the prompt for this. So we're going to get the raw request body as text, not JSON passed. Get the Stripe signature header. That's really the important bit. Use the Stripe webhook secret from the environment variables. Verify the signature using Stripe webhooks construct event. We're going to go into Stripe and set that up shortly. And then if verification fails, return 400 with invalid signature, and then only process the event if verification succeeds. Cool. Looks like I might have finished that. That's the prompt we sent off. So what does signature verification do? Stripe signs every webhook with a secret key. Your server uses Stripe webhooks construct event to verify signature. If it doesn't match, the webhook is fake, and only Stripe can generate valid signature, so it will reject it. Cool, so we're now going to go into the Stripe dashboard where we were before, and then we're going to go and configure this new webhook we're looking for, or a couple webhooks. Awesome, so let's head to the dashboard. I've got to open over here. Refresh that. Give it a second. Cool. So we can go to developers down here, and then select webhooks. Then we can click add destination. We'll use Clover. So we're going to enter checkout session completed, and we'll tick this box, and we'll click continue. And then we can also add this. I forgot to add that. Also add the payment intent, payment failed event. Then we can click continue, and then click continue again. and make sure Webhook endpoint opposed to Amazon Event Bridge selected for this project. Cool. So we can really call this anything we want. I'll just call it security endpoint. And then now we can add in our Vercel endpoint. So we'll go over to our, however you want to get it, but if we go to V0 here, well not V0, sorry, Vercel, get over to this, and then I'll just get this link here. Put it in here, but I'll get rid of this. Oh, so I just forgot to press enter. I'll just copy that in there, and so this is our like live webhook link. We could put localhost in there, but it's not really like, not a very good idea, given that we're not trying to set this up for local production or local use. We're setting it up for because this is a a public web application. Cool. So I'll click create destination, and we should get a secret. Cool. So I'll just take a screenshot of this page. Cool. So why do webhooks need signature verification? Without signature verification, an attacker could, as we just saw, send a malicious attack forcing various pieces of data into our system without our permission. The signing secret proves that this request came from Vercel. Sorry, not Vercel, Stripe. Why do webhooks need signature verification? Without signature verification, an attacker could send a malicious attack forcing various pieces of data into our system without our permission. The signing secret proves that this request came from Stripe. Cool. So now we're going to go and add this to our Stripe. Vercel. It's a bit bigger. Our Vercel deployment, because as I spoke about before, and the reason we added an environment variable, the secret key before, is because when this is deployed, it needs access to that. So I will copy the key across from the Stripe dashboard into here, and then we'll call it we can really call it anything we want as long as it's consistent. It's a Stripe. What should we call it? We could call it just note that name down. Oh, cool. Sorry, I did write it in there. I'll just change this name. Just take a screenshot of this.
how does your server know if Webhook is real or fake? The fake Webhook is rejected because it is missing a signing key from Vercel. Checks for this said signing, or checks whether the signing key matches from Vercel. Keep writing Vercel from Stripe. Apologies. So how does your server know if a webhook is real or fake? The fake webhook was rejected because it is missing a signing key from Stripe. Stripe webhooks construct event checks whether this signing key matches what is expected from Stripe. Awesome. Alright, so now we're going to go and verify that this fix has worked. So we'll just do that. Cool, so if we send the same if we send the same thing, we get a remote server returned a 400 bad request. So this is really clear that so you can see something like a 500 or other things. 500 if you set up your set up something wrong, if there was environment variables which are set up incorrectly. But 400 means it's been rejected by the server, and that's because something hasn't lined up. In this case, the signature request hasn't been filled. So, yeah, cool. We see this sort of 400 error, bad credentials, or bad request, sorry. If it still passes, I would definitely double check your environment variables folder, your .env.local, if that has everything you need. Yeah, definitely check that out. But we're all good. We've got a rejected, which is actually good in this case, because we don't want someone to be able to do this. Awesome. Awesome. So your server now rejects fake webhooks. The signature verification detected the invalid signature and refused to process the event. This is a cryptographic security in action, or is cryptographic security in action. Only Stripe can generate valid signatures, so good. This fake signature has been rejected. Nice. Cool. Yeah, we can again use the card and just have a look at the payments go through. We had a little look before because we weren't really following the thing doing that. So I'll just go through and fill this out so we can have a look. Put in some placeholder stuff. Cool. And we see a 404 here, but that's just the fact that there was no success page generated. You can see it has a success up there. Cool, so if we go and check the Stripe dashboard, we can see 3 failed, so that was the ones we were running before, over here. So these are, that's a fail, but we have 4 total, so the one we just ran would have worked, which is great. So super cool. Yeah, nice. Just pull up the thing here.
Awesome. So we see a failed payment, or multiple failed payments, and then a successful one, which is great. Cool. So that's the project. Apart from the secret mission, we'll go to the secret mission now. But if you see failed deliveries, then definitely go down that route. There's some information there about how you can go and debug that. Yeah, for sure. Cool. So we're going to go to discount codes now. Discount codes done right. How do platforms like Shopify and WooCommerce handle discount codes without letting attackers apply any discount they want? By now, you've built a secure checkout flow with server-side pricing and webhook verification. In the secret mission, you'll add a discount code system that allows the same principle. The front end can only send a code string, not control what that code is worth. Cool, so you've built a secure checkout and a webhook verification. Now let's add a feature every e-commerce platform needs: discount codes. But here's the thing, done wrong, discount codes are a goldmine for attackers. If discount logic lives in the front end somewhere, someone can open DevTools and just change discount percentage to whatever they want. Free products for everyone except you. Let's build in the secure way with server-side validation. So in this mission, secret mission, get ready to add server-side discounts to your checkout API and test the discount code flow end to end. So what's the secure way to implement discount codes? I'm going to add discount codes to my e-commerce store. The front end will send discount codes, but the server will decide whether these are valid codes and actually apply the discounts. So what's the secure way to implement discount codes? I'm going to add discount codes to my e-commerce store. The front end will send the discount codes, but the server will decide whether these are valid codes and actually apply the discounts. The security pattern. So we're going to send off a prompt to go and apply discount codes now. This is the same pattern used by Shopify, Amazon, and every professional e-commerce platform. Front end sends a code string like welcome20. Server looks up what the code is worth in its own dictionary. The server ignores any discount codes the front end might try to send that aren't in this dictionary. The front end is just a messenger. It never controls the actual discount amount. Cool. So we're going to open up Cursor Chat now, and we're going to send this prompt off. So what this does is it updates the checkout. So we're asking it to update the checkout API route to support discount codes. We add a saved discount codes dictionary with these codes, save 10, welcome 20. And we're going to accept optional discount code from the request body, look up the discount server side and apply it to the price. Silently ignore invalid codes. We don't want to reveal which codes do actually exist. It's important to never accept discount amounts from the front end. Only accept a code string that looks up its value server side. So why silently ignore invalid codes? Returning code doesn't exist versus code expired lets attackers enumerate valid codes by treating all invalid codes the same way. You don't reveal which codes are real. Cool, so why do we silently ignore invalid codes? Because we don't want to give away free codes or free discounts, free unwanted discounts. This prevents attackers from enumerating valid codes, getting discounts. So why do we silently ignore invalid discount codes? Invalid codes are silently ignored because we don't want to give away free unwanted discounts. This prevents attackers from enumerating invalid or valid codes, getting discounts. Cool. So we're going to add discount code input to the checkout page now that it's finished adding it to the API. So we're going to go into use the element selector. We'll head back from the success page. We'll just go to localhost 1000. We'll go to where you can add it wherever you want. We'll add it to this page here. So I'll open this and I'll select this element here, and then I'll send a prompt to add the discount code input field to this section. And as I spoke about before, this is a really useful tool to be able to click on a component that you're interested in, or an element you're interested in editing. You could probably say add the discount code input space to the order summary space section, and it probably do it, but more complicated stuff it might not do so well. So there you go. Anyway, it's completed now, so that's good. Time to see it work. So we can actually try the code that it gave us here. I think it said save 10. Let's see if this works. Cool. So we can see it's been applied. So the full cost of it, I think, was $5.99 if I'm not mistaken. Maybe 300. Sorry. Yeah, that makes sense. 10% off. And we can go and complete this purchase with this price. So why? We'll go to this tab because discount was applied. We see it's less than $300, $30 less, 10% of the full price. If the full price was charged, you'll be able to go to the community or use the ask feature here. Clicking on one of these buttons, it will open up a chat you can talk to our AI with. That didn't work, totally go to the community. But it did work for us, so we're just going to continue down this and learn a bit about why this is secure. So think about what an attacker could try. Attack what happens, sends fake, save 100 or any sort of big discount code to the space back here. Something that doesn't exist, but maybe it could for background use, and you don't want it to have any effect on their actual price. So yeah, and then the next layer of that is we've done this so that and stored it as a dictionary where the save 10 has the has an amount of 10%. You can set it as 20 or 30 or anything you want, but it's just crucial we're not entering numbers there directly. It's not just like you're applying it through the front end. Cool. So that's what it states up here. So where else does this pattern apply? Any user submitted value that affects pricing, quantity limits, shipping, calculations, tax exemptions. It affects the user's pay, validate it server side. Cool, so mission's complete. We can see that worked. And yeah, so we're going to go down this one. But if you have any troubles, certainly try these troubleshooting things. If you need any help, go to the community or use the ask feature here. Great options too. Cool, so we're just going to go in. I'm not going to clean up, delete stuff, but we'll walk through this anyway. Nice work completing this project. Let's make sure your secrets are secure. So security checklist, verify your secret key isn't committed in any committed code. Check that .env.local is in your git ignore. And if I'm keeping for testing or doing the rest of the project, then I'm going to go down this one. Moving to production, I can go and do that. Then if you want to remove everything, just leave it here. That's completely fine too. You can go down this route. So what were the key tools and concepts you learned in this project? The key tools I learned, I used include
So we use Vercel's secret manager. We use Cursor 2.0, and we also use Stripe. Key concepts I learnt. So include where to store sensitive information. That can be secret keys, or it could also be, we can put a separate thing, when to use webhooks and place secrets in, when to use webhooks. A webhook protection. And that for us was signing from, looking to type Vercel, Stripe. Cool, so what were the key tools and concepts you learned in this project? The key tools I used include Vercel Secret Manager, Cursor 2.0, and Stripe. Key concepts I learned include where to store sensitive information, secret keys, in my .env.local or inside Vercel's Secret Manager, and when to use webhook protection. So that for us was signing from Vercel. How long did this project take you? It took me approximately an hour and 20 minutes. Roughly an hour and a quarter. The most challenging part was understanding why webhook security is so important. So how long did this take you to complete? This project took me approximately 1.25 hours, and the most challenging part was understanding why webhook security is so important. Awesome. Thanks for doing this project. Why did you do this project today? Did this project meet your goals? I did this project to learn how to manage payment security on hosted web apps, just web apps that were hosted on web apps, specifically using Stripe. Another skill I want to learn is how to analyze my site's traffic using post-hoc. That's the next project, post-hoc stuff. So yeah, super stoked to learn that next. Next project in the series. Thanks for doing this project. I did this project to learn how to manage payment security on web apps, specifically using Stripe. Another skill I want to learn is how to analyze my site's traffic using post-hoc. Cool. That's a wrap. We will do a quiz now. Where should the Stripe secret key be stored for a Vercel deployed application and for local deployment? Directly embedded in front-end Java source code? I don't think so. In a publicly accessible GitHub repo? Nope. As an environment variable in Vercel .env. Yeah, that sounds right to me. What is the primary purpose of integrating Stripe for this project? To securely accept payments and manage transactions, to manage project's GitHub, to generate React components, to deploy the application to a hosting platform, definitely for payments. Which tool is used in this project to generate the initial e-commerce website? From a plain English description, we use V0 for that. What is the main security difference between a Stripe publishable key and a secret key? Publishable key is for live transactions, secret key is for test transactions. Publishable key is for safely exposed front-end code. Secret key must never be exposed in the front end. Publishable key is for issuing refunds. Secret key is for creating payment tokens. Publishable key starts with SK test, PK test. This one sounds the most correct to me. Go with that. Why is it crucial to define product prices server-side when creating Stripe checkout sessions? To reduce the load on the client-side application, to ensure that all payment methods are supported by Stripe, to allow dynamic pricing based on location, to prevent malicious users from manipulating prices sent to the front end from the front end. Sounds right to me. What is the primary purpose of Webhook signature verification? To confirm Webhook event originated from Stripe has not been tampered with, to provide real-time updates on status of the user's interface, to encrypt the payload, to automatically retry Webhook deliveries. I think this one looks right to me. Awesome. So what we learnt, how Stripe checkout reduces PCI compliance, to its payment card interface, the difference between publishable and secret API keys, why prices must be calculated server-side, how Webhook signatures prevent spoofed payment confirmations, and then server-side discount validation in the secret mission. Cool. Awesome. Project complete. Yeah, that's a nice quick one. Not too long. Definitely recommend it. It's a great way of starting to build on financial ops, FinOps knowledge, using one of the most popular online payment method, Stripe. Yeah, awesome. All right, well, I hope you guys enjoyed that, anyone that followed along, and I hope to see you guys in the next part of the FinOps series that'll be post-hoc looking at analytics. All right, bye for now.